Chapter 11, Section 1, Simplifying Algebraic Expressions. The objective of this lesson is to learn to combine like terms in an expression. Terms in an expression are separated by a plus or minus sign. Like terms have the same variable raised to the same exponent. Now that's important. Like terms have the same variables raised to the same exponent. To simplify an expression, you perform all possible operations, including combining like terms. Let's take a look at this expression down here. We have 7x plus 5 minus 3y plus 2x. The terms from the expression above are, we want to find the like terms. I see a 7x and a 2x. Now, keep in mind that I did not highlight just the term, but also the operation sign in front of the term. That's very important. So I did not highlight just 2x, I highlighted plus 2x. The x variables here are raised to the same exponent. If there is no exponent, it is actually a 1. That will be explained more in depth later. But 7x and 2x are like terms. 7x and 2x. Now 7x is x 7 times. So it basically is x plus x plus x plus x plus x. X 7 times. Now we're going to combine that with 2x, or x 2 more times. So x 2 more times, and we're going to combine it using this addition. So now I have 7x's plus 2 more x's for a total of x 9 times. So we bring down the variable and we simply add, because it's telling us to add right here, 7 and 2 for 9. Now we do have 2 more terms, 5 and 3y. They are not like terms, so we are just going to bring those down. So we're going to bring down plus 5 minus 3y. Now this is our expression simplified. We cannot do any more operations with this expression. That's as far as we can take the expression. So 7x plus 5 minus 3y plus 2x simplified equals 9x plus 5 minus 3y. Let's take a look at example A, combining like terms. I have 14a minus 5a. Now 14a and 5a are like terms. They both have a number multiplied by the variable a, and the exponent truly is a 1 here on both of these, so they're like terms. Now remember, 14a really is a 14 times, so it would be a plus a plus a. This would happen 14 times. 5a is a 5 times, but I want to take that away, so it's going to be minus a, minus a, minus a, minus a, minus a. Now these 5a's that are being subtracted will cancel out 5a's that are being added. So this is what we are left over with when we combine 14a minus 5a. So 14a minus 5a will be these a's right here, and that comes out to be a 9 times, or 9a. If the variables are the same, if they're raised to the same exponent, they're like terms. 14 minus 5 is 9. And don't forget the variable a. In this expression, I have 7y squared plus 8 minus 3 times y squared minus 1 plus y. Now we're combining like terms. I see 7y squared, and there's another y squared over here. So 7y squared has a like term of 3y squared, but notice I mentioned this before. You include the operation sign in front of the term. So those two terms are like terms. Now I'm going to combine those. 7y squared is really y squared 7 times, so it would look like this. 3y squared would be y squared 3 times. However, that's being subtracted. So it would be minus y squared minus y squared minus y squared. These three y squares that are being subtracted would cancel out 3y squared that are being added. And we'd be left over with y squared 4 times, or 4y squared, after I combine those like terms. 7y squared minus 3y squared would equal 4y squared. Now we're going to bring that down to our answer down here and save that for later. Let's go back to the expression. I don't see any other term that has y in it, but I do see 8 and this minus 1. 8 and minus 1. Notice I'm including plus 8 and minus 1. Those are like terms. So I'm going to have 8 minus 1. That's going to come out to be plus 7. So now I have 4y squared plus 7. And let's not forget this last term that does not have a like term. So y will come out to be plus y. So 7y squared plus 8 minus 3y squared minus 1 plus y is simplified to 4y squared plus 7 plus y. And this is as far as I can take that expression. In these two examples, example C and example D, example C, we're going to see the distributive property. Now remember, with the distributive property, we have a number on the outside of the parentheses, and inside we have two terms. Terms are separated by addition or subtraction. Now I'm going to take the A and multiply it by B, and then I'm going to take the A and multiply it by C. Because there's addition, I'm going to add between them. So it's going to be AB plus AC. An example of that would be 2 times the sum of 3 and 5. It would be 2 times 3 plus 2 times 5. And it's shown right here. In this first example, letter C, I have 3 times the sum of C and 7 minus C. First, I'm going to simplify by using the distributive property. So I'm going to take 3 and multiply it by C, which will be 3C. Then 3 multiply it by 7. This addition sign is going to come straight down. And let's not forget the minus C on the outside. Now let's continue to simplify this. 3C, bring the addition sign down. 3 times 7 is 21. And then minus C. Now we're going to look for any like terms that we can combine. I see a variable C raised to the exponent of 1. This variable C with the same exponent, so 3C has a like term of minus C. Again, I include the operation sign in front of the term. If I combine 3C and minus C, I'm going to come up with 2C. Don't forget the plus 21. Now this term, 2C plus 21, that's our answer. You were asked to simplify 3 times the sum of C plus 7 minus C. That is simplified to 2C plus 21. That's as far as we can take this problem. In example D, we have x plus 3x equals 48. Let's take a look at the left side. There's no math operations to perform except for simplifying. I see the term x and I see the term 3x. Now it would be x plus 3x would come out to be 4x. On the right hand side I would have 48. Now there are no more like terms, so we need to isolate the variable. When we isolate the variable x, we ask ourselves what math is happening to x. X is being multiplied by 4. Multiplication would be undone by the inverse operation of division. So I divide the left hand side by 4 as long as I divide the right hand side by 4. These 4's will divide out and I will be left with x on the left hand side and 48. Remember, this fraction bar truly is division. 48 divided by 4. So x equals 12.